Hi everyone. In this short video we'll look at expanding the break-even analysis out when we have more than one product being sold by the company or by the business. So in a previous video we had a look at setting up the break-even analysis, which is expanding out profit equals revenues minus costs all the way down to profit equals price per unit times quantity minus variable cost per unit times quantity minus fixed costs. And a break-even is a zero profit. But that's all well and good when you've got a company selling a single product, but it's pretty rare nowadays to see companies of any nature selling only one thing. They often have multiple product lines. Now the way, at least with a couple of products we can do this, is to work out a weighted average contribution margin. So when we look at this, we have three products: Citronella, DEET, and Mean Green. We have a price per canister, so the price per unit of $11, $15, and $17. We have variable cost per canister of $6, $12, and $16, and with a total cost of $260,000. Now when we have a look at this with the setup we have at the moment, which is profit equals price per unit times quantity minus variable cost per unit times quantity minus fixed costs. The fixed costs, that's easy, that goes down into fixed costs. Where the problem lies in, we have three variable costs per canister. How do we attach them all in? And we have three prices per canister, and how do we load them in to this equation when we only have one set fixed cost which runs across all of those products? And the solution to that is a weighted average contribution margin, as I already alluded to. I did give the game away a little bit. So to calculate that, because once we've got the weighted average contribution margin, we can just put that in to the formula and just work on it as normal. So the thing that we need is the contribution margin per unit. So for each unit, for each product, we have $5 in contribution margin for Citronella per unit, $3 for DEET and Mean Green. Whilst it's the highest price product in the market, it has quite a high variable cost and it only contributes $1 per unit. You sort of wonder why they keep that line going, but that's a story for a different day. So step one, work out the contribution margin per unit for each of the products. Step two, we add in the sales mix. Now the sales mix is the proportion of the total sales in terms of units for each of these products. So 20% of the units sold are Citronella, 40% are DEET, and 40% are Mean Green. We then calculate the weighted contribution margin per product. To get this, we take the contribution margin per unit for each product and we multiply it by the sales mix for that product. So for Citronella, it's $5 times 20% gives you $1. For DEET, it's $3 times 40% gives you $1.20. And for Mean Green, it's $1 times 40% gives you 40 cents. The last step is to just simply add up each of those weighted contribution margins. So the $1, the $1.20, and the 40 cents gives you a weighted average contribution margin of $2.60. So for each unit that is sold, there's a weighted average contribution margin. It will provide $2.60 to paying off fixed costs. And again, that's assuming the 20-40-40 sales mix. We then take that $2.60 and we put it into the formula. So profit break even is 0 equals the contribution margin, $2.60, times quantity minus 260,000 units. Add $260,000. $260,000. Add $260,000 to both sides, which gives you what we see here. swap sides, divided by $2.60, and that is your classic break-even equation, which is break-even quantity equals your total fixed costs divided by your contribution margin, which in this case is 100,000. So there are 100,000 units need to be sold to break even. But there's one final important thing that needs to be noted when you have a multiple product environment, is that 100,000 units needs to then be split up across the different types of units, the different types of products being sold. So in this case, we've got a 20-40-40 mix. Citronella has 20,000 units to break even, DEET 40,000, Mean Green 40,000. And that is how you do a break-even analysis with multiple products.